basically what happens is that in science, if you, in any defense, like so many defense I go to, people in the master's, PhD defense, and they present the data. And the very first question the people who are in the defense committee are going to ask is that what is the margin of error? So for every data, you cannot say, okay, I've got this number. There you are going to be asked, what is the error? How much up, how much more, how much less the number could be. So that's the margin of error, and that will be asked in every defense. So what happens in this case, since we cannot have that kind of data, so the next thing to do is to check different software. So we check one software, and you check another software, and that will give you indication of what kind of error is there. So I did that again for the right ascensions of Alcor. And so now I have done, what I have done is I have taken their positions in two software. So we got a Stellarium software, and I've got the Voyager software. Thank you, Ritujaji and Sangam Talks for giving me this opportunity. This is a very important topic. So I'll make this presentation, and this will be a three-part presentation. So this talk is dedicated to Professor V.N. Narhari Achar, late professor. He was a pioneer who did a lot of work in using the astronomy software for dating of our texts. And Sutiji has already introduced me. So I have very deep interest in ancient Indian history and astronomy. For my work is in the area of metallurgy and material science, developing processes for mineral processing, metals processing. So this, the topic today is whether there was an epoch of Arundhati and whether it can be dated. And the reason to do this is that this dating of Mahabharata to 5561 BCE has become very, very popular. So it needs to be scientifically examined. And also the reason is that it's very important is that our traditional dating of Mahabharata is 3102 BCE. But according to this criterion developed by Mr. Oak, Mahabharata could not have happened any time outside of 11,091 BCE to 4,508 BCE. So clearly what he has found is contradictory to our traditionally held belief, traditional dating. So how did he come to this? We'll discuss this, and why it is wrong. That's what we'll go into. So basically, the basis for this claim is this text, this verse from Mahabharata in Bhisma Parv. And as we know that there are we have got the Gita Press edition, but we also have a critical edition by Bhandarkar Oriental Research Institute. And they don't match most of the time. So basically, there are some verses that are considered not to be standard by Bhandarkar Institute. So I have tried to also give both references. So in this case, they are same 2.31. And in this one, it is claimed, it is said that Arundhati has left Vasishtha behind. So Vasishtha has come behind Arundhati, and it's kind of among the shocking statements in this part of Mahabharata. So what we will do is first get into the details of Arundhati and Vasishtha. So Arundhati, here we give the scientific information about Arundhati and Vasishtha. And on the left, you see that the Vasishtha star is identified with Mizar. And these are information. The magnitude is 2.2. And Arundhati is identified with Alcor, and the magnitude is 4.01. So if the magnitude is less, it is brighter. So the Vasishtha is much brighter than Arundhati. So if you look in that area, first you will see the Arundhati, and then you try to look further, and then you will be able to spot Arundhati. And here I show using the software Stellarium that you can see that this it gives you all the information about Myjar. So it's here. And this is part of the Big Dipper. So Saptarshi is 1, 2, 3, 4. And then in this handle in the middle, we have got Vasisht Rishi, we call Myjar. And on the other side, we have got for Alcor. And in that case, you'll have to focus further on it so that you'll be able to see that there is Arundhati next to Vasisht. But in fact, if you look closer, further magnify, and this is what the astronomers have found, that they are not just two stars, but they are actually 6 stars. So the Alcor is also is a double star, so very faint. So obviously you won't be able to see with the naked eye. Then you will have to some of them you can see with the binoculars or the telescope, but some of them are also identified using their spectroscopic analysis. So they are called spectroscopic doubles. So the Myjar itself has got two A and B, and then further looking at them, they are also double stars, the B itself. So we got total of 6 stars in the system of Vasisht and Arundhati. And here it gives you more information that we just showed, that there are 6 different stars in the system. You can read about it from this reference. So then we have got one observation about Arundhati going ahead of Vasisht. So we need to know in what context it has been said. So to understand that, what I have done here is that I have produced here many verses that are before this observation and many verses after this observation. So basically, in the vision purpose, so the context is that the war is going to start, and the war is such a big war is going to happen, and there are a lot of bad things are happening because there will be so much destruction. So these are all like omen. So this Bhagwan Vyas is telling the trust that there will be a great like carnage. So many people are going to die, and I see lots of omen. I suppose से अपशकुन दिखाई देते हैं. And then we have got a whole list of things like we have got a Purnima, so we have got a full moon, but we don't see the moon. And then we have that the statues of the gods, they are vomiting blood. Then we have got like this dundubiyan bina bajaye baj uthte hain. So nobody is trying to play them, and they start playing by themselves. Rath bina jote chal padte hain. So basically the chariots start driving by themselves. And after that, we have got this verse among that is that Arunti has left Vasisht behind. And then we further continue, and you see that the sign on the moon has been obliterated, it's not being seen. And we have, without the clouds, we have got all this thunder going on. And then वाहनों की आंखों से आंसुओं की बूंदें गिर रही हैं. So there are tears falling from the chariots. And then you see even it gets even more surprising. Then गायों के गर्भ से गधे पैदा होते हैं. So you can think of that, that donkeys are being born out of the cows. This is even worse. You can just read it. Flowers are coming out without the season. And the pregnant women, they are not giving birth to kids, but bhankar jeev, so very wild animals. And then you have got teen sing, char netra, panch pair. So the animals with like 3 horns, 4 eyes, 5 legs. So these kind of things are happening. And we continue like that. They have got Garur Pachi with so we have got a bird with a horn. Again, this घोड़ी गाय के बच्चे को जन्म देती है. The calf being born out of horse. कुतिया के पेट से सियार पैदा होते हैं. So you can see that wolves are jackals out of being born from the dog. कुछ स्त्रियां एक ही साथ 4-4, 5-5 कन्याएं पैदा करती हैं. जो पैदा होते ही नाचते गाते हंसती हैं. So 4-5 kids being born, and they start dancing right after birth. And so we continue that, and we say that कुमुद आदि जलीय पुष्प वृक्षों पर पैदा होते हैं. So all these flowers like lotus and all, they instead of being in the water, they are growing on the tree. So it continues with all these kind of abnormal things that are happening. We got birds with 1 eye, 1 leg. Then we have got the rain of blood in the night. And even the rivers are flowing in the opposite direction. So what you have is that you have got one observation among a set of descriptions that are all very out of normal. So can you really take that observation seriously? And here I have shown a quote from Srikant Talgeriji, a very noted scholar. And this is what he says. So in short, far from showing that this is an astronomical observation being made during the epoch of Arundhati, the reference in fact shows that the normal position is that Vasishtha is ahead of Arundhati. So it is only as an omen, as opposed to while everything is appearing to be the opposite of the normal, that Vyas sees Arundhati moving ahead of Vasishtha. So Oak's revolutionary discovery could have been made even more revolutionary by actually locating an epoch when the moon became invisible on full moon night, and the images of gods and goddesses came to life in the ways described in the text. So basically, if you look this verse in the context of what is being said, then you clearly know that this is the normal way of that time is opposite of that. So it's actually the Vasishtha is ahead of Arundhati. So, but Mr. Oak insists that this has to be taken literally, and that defines the date of Mahabharata war. So Mr. Oak is claiming that it has to be taken literally, and this defines the date between 11,091 and 4,500 around BCE. And so what basically tells you that in his own scheme of things, this Arundhati had been leading for 5,533 years already. So if it's already 5,530 years, so it's a normal thing, and even continues that for 1,053 years. So why would this be cited among the list of unnatural things? So what we need to do, what I did, is also look for what is being said about Arundhati herself in Mahabharata. So do we have any confirmation of this, whether Vasishtha is ahead or whether Arundhati is ahead? So what I did is look for Arundhati in Mahabharata. So what I did is I found an electronic text of Mahabharata, and I searched for Arundhati electronically. And I found that the Arundhati is mentioned 31 times in Mahabharata. Now, if I list all of them, I have got the list of, all the verses with meaning and everything, but of presenting all of them will be, of course, boring and not serve the purpose. So I'll just present some of them and give the whole list, and people can check. And also I'm going to put it on my blog, all of these verses with exact meanings and everything. And I'd also like to note here that my good friend Sri Ashish Naredi, he had also compiled this list of Arundhati in Mahabharata. He had shared the list with me, and I had independently searched myself also, and both of our lists match. So these are the 31 mentions of Arundhati. So the very first one I found was in Mahabharata, Adi Parv. And this is very important because the context of this is that Draupadi had just been married, and Kunti is blessing her. And here it is being said that she should also love her husband, follow her husband, just like Arundhati does for Vasishtha. So clearly in this marriage which happening just before the Mahabharata war, and at that time, obviously, according to this verse, the things are normal, like Vasishtha is ahead of Arundhati. And this is what has also been, the point has been also been raised by Dr. Jayashree Sarnathan, very good Mahabharata scholar, very knowledgeable. I've been in touch with her also. And say that if the Vasishtha was doing behind Arundhati at that time, during Draupadi's marriage, if we accept Mr. Nilosh Oak's version, then why would Kunti be advising Draupadi to follow just like Vasishtha Arundhati is doing to Vasishtha? So obviously, we have got this verse that is clearly opposed to the interpretation by Mr. Oak. Now, rest of the verses, I'm just giving here the list of these verses, both in the critical edition and the Gita Press edition. So if you are interested, you can check, or you can wait for my blog where I will put it out. So these are all the verses, again, 7, 8. And then the 9th mention is the one that is the critical one, which says that Arundhati has left Vasishtha behind. And then we have got all these lists from. So just I'm putting it all together in case anyone wants to check it. So these are all. And so I've gone through all of them, and none of them give any impression that Arunti was ahead of Vasisht. In fact, the general that feeling that you get from that is that things are normal and Vasisht is ahead of Arundhati in all parts of Mahabharata, wherever Arunti is mentioned. In some cases, of course, the timing is not clear, so we don't know what time we are talking about. So now we get to the astronomy of it. So if Arunti was ahead of Vasisht, how do we know that Arunti was ahead? How did Mr. O come to the conclusion? How did he derive the interval that is under consideration? So basically, to know that, we need to have a simple astronomy basics. So basically, what we have here is celestial equator. And so that's basically, if you take the equator into the sky, just think of projecting it onto the sky. You imagine a very large sphere of arbitrarily large radius. You call it celestial sphere. And you imagine that all the planets, stars are all on that. And then you get their coordinates, which are basically angles at which you will see. So all these coordinates are basically angles. So that we have got celestial equator. And just like we have got the North Pole and South Pole, so basically you extend them onto this largest sphere, a celestial sphere, and you get North Celestial Pole and South Celestial Pole. So basically on that, you basically find the position, just like you find the position on Earth with the longitude and latitude. So in this case, you'll measure the longitude along the equator. We call it right ascension. And we measure the latitude going towards the pole. And here we call it latitude. And for in this consideration, we call it declination. So we have got the declination equivalent of latitude. And we have got right ascension, which is equivalent of longitude. So these two what we need to measure star positions. So now what happens is that the longitude we measure here, let's say in the degrees, but for the stars, for this equatorial system, we also measure, specify it in terms of hours. So you know that in the circle we have got 360 degrees. And here we say it goes to 24 hours. So basically each hour is going to be equivalent to 15 degrees. So what is most important is that when you see the stars moving through the night, then you will see the one that is ahead will be having a lower right ascension, so a lower longitude compared to a star with a higher right ascension, so that will be behind. And that's all. That's what is important for this calculation. So here we have got. So I've gone through all the data that Mr. Oak has provided in his book, which is when did the Mahabharata war happen. And over here you see that this is the data provided by Oak, and he has gone from 2010 CE to 13,000 BCE. Given the right ascension of Arundhati of Vasisht, then he has taken the difference. So basically the difference is the difference between the right ascension of Alkor or Arundhati minus that of Maijar or Vasisht. And here he has given the difference. And what you basically see here, that around this 4,509 BCE, this value is positive going backwards, and here it becomes negative. And it stays negative till about 11,091, and then it becomes positive. So when it is negative in the software, that's when Arunti is ahead of Vasisht. So that's how he has got the timing that Arunti was ahead of Vasisht from, let's say, 4,509 BCE to 11,091 BCE. So he has given this, so in the arc seconds, and then I have just divided it by 60 to get into arc minutes, because that's where it will be generally specified. So now what I have done, that was his information. So I have gone through the same software that Mr. Oak used, it's a Voyager 4.5. And then I have made the same table, so just to verify what he has given. And so here I give all the information that I got from the software. So you get into the right ascensions in hour, minutes, seconds. I made an Excel file, put all this data, calculated everything seconds. So here you see ROI 2022. So it's up to here is my calculation from the same software, and in the seconds and the minutes. And here I reproduce from what is in the book, and you can see that they both match. So we have reproduced what Mr. Oak has described in his book. And now I have plotted this data just to make it more visual. So basically you see that from the time, so this is the difference, and it goes so around this here, and this is the y-axis of 0. So this becomes negative from here up to here, from let's say 11,091 to that 4,500. So this part, that is what is defined by Mr. Oak as the epoch of Arundhati. I have also gone to the software. Here I am producing the sky maps for the same, and to know exactly when this happened. So I went to the time. So August 5th of 4,588 BC, and you can see here. So this is for, I say the name here, Alcor Arundhati, and here the right ascension, you can see 3 hours, 3 minutes, 32.64 seconds. On this side, I did for the same time for the Myjar Vasisht, and you see that right ascension 3 hours, 3 minutes. So this is the exact date in the software. That's when both of the right ascensions became equal. And so that's one side, the 4508, and then we go back to 11,090. So I found January 13, 11,090 BCE. That's where the right ascension here, 21 hours, 16 minutes, 7.87. So you can see that exact match, 21 hours. So that's when they became exact. So in the software, between this time, Arundhati was ahead of Vasisht. So that's confirmed in the Voyager software that Mr. Oak used. And of course, we need to use multiple software to see what other software is showing you. So in this case, I used the Stellarium, and in the Stellarium, the dates are a little different. So here, September 15, 4480 BC, and you got Alcor Arundhati and right ascension on the date. Here's 3 hours 8 to 1.8, and here 3 hours 8 minutes 1.8 seconds. So exactly on this date in the Stellarium is matching on 4,480, a little bit different. And on the other side, instead of 11,091, I'm getting September 15, 11,386 BCE. You can see here RA on date, 21 hour 5 minutes 59.98, 21 hour 59 5 minutes 59.98. So in the Stellarium, the dates will be between these. So what I have got as in terms of first confirming the data by Mr. Oak, that it was indeed in the, if you use the Voyager 4 software, the interval is between 11,090 BCE to 4,508 BCE. If you use the Stellarium software version 0.20.4, then the timing is between 11,386 BCE to 4,480 BCE. Now, obviously, when I look at this data and I check that, I'm thinking of it like, why would Arundhati go ahead of Vasisht? So did the distance between Arundhati and Vasisht change? Or is it just because of the orientation? Is it a distance changing, or is it the orientation changing? So then I looked into the distance between Arundhati and Vasisht over these last 15,000 years. So it's pretty simple. I mean, from my side at least, I mean, it's high school mathematics. So you find out the distance between the stars, you can use this formula. And this is the link, the reference for that. And basically, if you want to find it, you need to know all of this. So you need to know the right ascensions of the stars and obviously the declinations of the objects. So basically the two stars, if you know their coordinates, the right ascension and declination, or longitude, latitude, for both of them, then you can calculate the distance using this formula. If you don't want to use the formula, then there is a resource here on internet. You can go to this website, and here you can just input the coordinates of the stars. It will do the conversions and it will give you a calculation. Like I put there, and it says that Arundhati and Vasisht are 11 minutes 42.3 seconds apart. But of course, for so much of the data, I cannot use this website. So I had to make my own Excel file to do that. And I use the Excel file. I input all the data from the Stellarium. So for this, I used the Stellarium software, and I calculated the distance between Vasisht and Arundhati over this time period from 12,000 BCE to 2000 BCE. So obviously, I needed all this information, right ascension of Myjar, so that I got from the software. And then I calculated the arc minutes, and then I calculated the alpha 1. So that's in the degrees you need for the formula. And same for the Arundhati. So that's all the data. And then I calculated alpha 2 that goes in the formula, and that's in the degrees. And the same for the declination. We get this information from the software. Then we calculate convert that into the degree using the Excel. Same for Arundhati. So now we have got all that information for all this period for the delta 1, delta 2, all the alpha 1, alpha 2. So once we have that, then we can calculate what's the distance. And this is what I calculated. So from 12,000 BCE, distance between Arundhati and Vasisht was 12.43 arc minutes. And it has been reducing very, very slowly. And to our time is at 11.81 arc minutes. So it has not really changed much over the last 14,000 years. We have only from 12.43 to 11.21. So still like 12 arc minutes. We got only what 0.6 arc minutes. So very, very, very small change. And you can see that that's how it changes. So basically, see, once you look at this kind of information, and people who, what they do is they just use the software, and they don't know what the software is doing, how the software is doing all these calculations. So obviously, we don't really have all that information for the last 14,000 years. I mean, we have been doing astronomy only, serious astronomy like this only for a couple of 100 years. So what you do basically is you make all these assumptions, like what we are seeing now, or we saw it 100 years ago. Those are the same values that have existed for, say, 14,000 years back. So you do a lot of extrapolation, make assumptions. And so basically, that's why you have got a linear plot, because what we are doing, we are just assuming that the proper motion of Arundhati and Vasisht is remaining constant. So if you go in the software and you go over the 14,000 years, you'll see that they're using the same value. And that's why you are getting a very linear constant value. So if the distance has not changed much, then obviously it is the orientation, and that's basically because of precession that is giving rise to this phenomenon. So we have verified that, and now we are coming to the question whether this interval has any scientific meaning to it. Can we believe this interval? And this is what we have presented. This is the epoch of Arundhati, and we have got all that data for that. So now we have got a very important question that comes in. So basically what happens is that the whole calculation of this interval is based upon the right ascensions, the difference between the right ascension. But the right ascension itself is calculated on the celestial equator. It is not calculated where the stars are actually located. And that makes a big difference. So we have got just one quote just to tell you. So basically what's happening that we have got, let's say, celestial North Pole. And then we have got these two stars. And then you have got celestial equator far away from it at 90 degrees. And you are drawing lines from there and through these stars. So basically, if the stars are closer to the pole, then the effect is going to be highly magnified. And that's what it says that if you converge at the celestial poles, if they have got two stars and they are 1 hour apart in the right ascension, so that's like 15 degrees, but they are not necessarily 15 degrees apart actually. And this is the illustration of that. So what is happening? So let's assume that this A and B, these are the Arundhati and Vasisht stars. So they are here, and their difference is only this much. But right ascension is being measured here at the celestial equator, and that's CD. So that's because we are drawing lines from this celestial poles like this. So you can see that if you are here, if you are going to be very small difference, but if you are going to measure the right ascension, you are going to highly magnify it. So depending upon where these stars are, closer they are to the pole, this whole distance is going to be more and more misleading. So we got to find out what exactly is this number, what is the actual difference in their effective right ascensions. And so that one is again easy to calculate, and this is the reference. And we have got that this AB, if you know this declination, is then simply the right ascension, and you multiply with the cos of declination. And the whole derivation is given at this website. So what I did then is calculated what will be the real right ascension difference between Arundhati and Vasisht over all these last 14,000 years. So to do that, we have got the declinations here for Myzar and Alcor, Arundhati and Vasisht, and you can see that they are very close stars. So we take an average for that declination. So I calculated the average. And then, of course, we have got the right ascension difference. And then we calculated that effective right ascension difference. So it's actually the distance along the declination. And that comes to this. So this tells you a lot. So we have already gone through the distance between Arunti and Vasisht, and we saw that it was just about 12 arc minutes over all this time, just a little bit up and down. But what happens here, you can see that you can get the difference as much as 46.34. So what is actually maximum 12 arc minutes difference can be amplified to 46 arc minutes. So if you go to the effective difference, which is along that declination, that is more representative, then we find those numbers are much smaller. So in this case, for the RA difference, which was between this 11,091 to 4,500, when you look at that, you get up to say 9.35 arc minutes difference. But when you actually where the position of the stars are, there the difference is much smaller, and they go only up to 3.44 arc minutes during this whole period from 4,500 to 11,090 BC. So this is a very much smaller number than this, and you can also see that they are much more representative because they also go only up to 11.54. So it all depends upon how the two stars are oriented at that time when they are being observed. But they are representative because the 12 about that is the maximum difference between that 12 arc minutes, and that's where they go up to limit. Now this tells you a lot. If you look at that, then you see that over here it has become this RA difference because the orientation has changed, and that has become much larger. So you got 8 to 11. And what we need to also keep in mind that the limit of human eye to detect the position of stars, the differentiate, is about 5.5 arc minutes. So only around this time, somewhere after 4000 BCE, is when people will be able to notice that Vasisht has really is ahead of Arundhati. Because before this time, all you have got is a range which is below the detection limit. So even if, let's say, Arundhati was ahead of Vasisht in this time, nobody could really tell. They will all look exactly the same point. Nobody we can tell whether Arundhati was ahead or whether Vasisht was ahead, because it is below the detection limit. So now showing it graphically, that you can see that these blue lines gives you the RA difference from the software, and it gives you like a much exaggerated view. Goes up to like say what was that 46 arc minutes, but actual is only much less, only like 11, 12 arc minutes is the effective distance, the distance where the stars actually are. And during this period of the epoch of Arundhati, the difference lies much smaller below the detection limit. So that's what we are seeing here, that we got up to 46 arc minutes, but the stars are actually only 12 arc minutes apart at any time. We have seen that. And so if we look at that, so effective difference maximum was only 3.5 arc minutes. So only after in 4th millennium BCE, and that's why we get that closer to the traditional date. And we know that at that time, people will be able to see that Vasisht was ahead of Arundhati. And here I give you another reference from people who are really doing visual astronomy. And here it says, observing with the naked eye, and you see that I got 5.5 arc minutes resolution. See that everyone can see the difference between Mizar and Alcor, Vasisht and Arundhati, because they are about 11, 12 arc minutes, so it's easily visible, the difference. But he says that another pair that will test your observing skills is between Omicron 1 Cygni and 30 Cygni. And they are separated by this much. And you can see that you will need to look with determination to split this pair. So you really need to be very, have very good eyes and see a difference. But below 5.5 arc minutes, you cannot really tell the difference with the naked eye, which we assume for Mahabharata. So we cannot separate less than 5.5 arc minutes. And of course, Mr. Oak can claim that sage Ved Vyas could see Arundhati ahead of Vasisht, even with that little difference. But at the same time, he's not being consistent, because he also claims, and we'll come to that in the later presentations, that when there is a gibbous moon, so even in the 10th day, he says that Ved Vyas is representing as the 15th day or the full moon. So 10th day, 11th day, 12th day, 13th day, he claims they are all being described as full moon. So if Ved Vyas cannot differentiate between 10th day moon and 15th day full moon, How can he differentiate that? So obviously he has got a complete inconsistency in his approach. So now we have done quite a bit of the analysis of the positions. And now we go into the final part is what do the astronomy softwares themselves say? What kind of accuracy they have? And for that, again, I did a lot of search into what goes into this software. How can we be sure what, if see that when you use the software, it will give you a value. Use it again, it will give you the same value. So you'll get very precise values. But is that value really representative of what was happening? What was the real position of the stars? And we have got a very important presentation. It was in this conference, Italian Society of Archaeoastronomy by Dr. Elio Antonello. And of course, you go into like what kind of research they do, what kind of person. And you know that he is a lot of work in the archaeoastronomy. From 2004 to present, he's the president of the Italian Society for Archaeoastronomy, a long career in astronomy. Also, he was at this INAF, which is the premier institute for astrophysics in Italy. And this is what he says. So basically, we don't get to know the details. We are just using the software, but we don't know how the software is giving you all these values. So we have got so many variables trying to calculate. So basically, what we have is a set of complex differential equations, and they are trying to solve these equations. And then you make so many assumptions about the constants, about the variables, and then you come up a number. So how much reliable, how much faith you can have, like how accurate are they? So the eccentricity of the ecliptic, obliquity of or inclination of Earth's rotation axis. We got intersection between ecliptic and equatorial plane. We've got the longitude of the perihelion, inclination and longitude of node. So you have so many types of variables, and they are all changing with time. And our observation is only limited to a few hundred years. And then you use trigonometric expressions with amplitude, frequencies, phase terms. You see, there are so many things happening behind. We are only seeing a visual representation. But how that representation has come, it has got lots of variables and constants and lots of assumptions. And this is the most important part of that. So we did it for the time interval of 10,000 years. We estimate an accuracy of some arc minutes and the corresponding uncertainty in time of the given coordinates of a star in the sky of several centuries. So basically, if you try to fix the position, then you have uncertainty of several centuries. Otherwise, if you have the accuracy of many arc minutes, even if it gives you some position, it could be off by many arc minutes. So, however, we remark that the evaluation of the precision of the results of the computation requires a comparison with the real observations. And this is what is very important, because we do, I do a lot of work I've done on the simulations. And what you do with the simulations, you try to solve these equations, but how do you know they represent the reality? So like, let's say in the metallurgy, you do these mathematical modelings, but you got to have some other data. So you do also physical modeling. You make a small model, physical model, you do all those variables, you do the test, and then you compare with your mathematical modeling. So for the validation of the mathematical models, and that's what these are, the simulations, you need to have the real data to compare with. We remark that the evaluation of the precision of the results of the computation requires a comparison with the real observation. And that means a time interval of just few centuries, but we have data only for few centuries. Therefore, in principle, the validity of the results very far in time cannot be assessed for any model of the Earth dynamics. So really, if you go like 10,000 years, 7,000 years back, you really don't have any way to know whether what you are getting by this simulation, by this software, really represent what was at that time the position of the stars. So basically, what we have is that the maximum difference in the right ascension in the software was only 8.6 arc minutes. But if you go to the effective distance, it was only 3.5 arc minutes. And that is well within the error margin of the software. So we cannot make any conclusion about this interval when the Arunti was ahead of VASIST. So basically, Oak has made the claim considering that the software is exactly accurate, but he has not considered what kind of accuracy the software has. And since the software does not have that kind of accuracy, the claim of Arunti being ahead of VASIST between 4,508 BCE and 11,091 BCE cannot be held true. It cannot be. it cannot be determined. And I have done further work to show that. So in that case, so basically what happens is that you, in science, if you, in any defense, like so many defense I go to, people in the master's, PhD defense, and they present the data. And the very first question the people who are in the defense committee are going to ask is that what is the margin of error? For every data, you cannot say, okay, I've got this number. There you are going to be asked, what is the error? How much up, how much more, how much less the number could be. So that's the margin of error. And that will be asked in every defense. So what happens in this case, since we cannot have that kind of data, so the next thing to do is to check different software. So we check one software and you check another software, and that will give you indication of what kind of error is there. So I did that again for the right ascensions of Alcor. And so now I have done, what I have done is I have taken their positions in two software. So we got a Stellarium software and I've got the Voyager software. And here we got the ascension of just for Arunti at the same time. So we take 1st of January 12,000 to all these dates and all the way up to present 2021. And then at the same time, I check what is the position in Stellarium and what is the position in Voyager. And you can see they look similar, but there is a difference. So let's say for here, we set to 4.59 and 43 minutes and 41.72 seconds. Now you have to remember that we have to multiply that by 15 to change to the arc minutes, because 24 hours equals 360 degrees. So we did all that calculation in Excel, and you see that for the same time, same position, all those times, there's a difference between these two software. And here is the difference. So we go up to 5.72 arc minutes to 13.61. So between these two software itself, at the time when you were talking, let's say 5,500, there's a difference of 13 arc minutes in between these two software, while we are claiming that few arc minutes difference between the Arunti and Vasisht right ascension. This is continues from 12,000 to 2021 for Arunti. And then I did the same for the Vasisht. So compare the position in two software at the same time, all the way from 12,000 to 2021. And again, we get the difference from 6.212 arc minutes to 14.32 arc minutes. You can see that the difference goes to 14.32 arc minutes, while the claim of difference, the difference is claimed is only maximum 8.5 arc. So what we have is that we are being claimed that the Arunti was ahead of Vasisht for 8.6 arc minutes. That's the maximum between this time. If you go to the actual stars and do the effective declaration, but we have Arunti was ahead of Vasisht, let's say by only 3.5 arc minutes. But if we compare the error in the position between those softwares, that's already 13 to 14 arc minutes. So we cannot really validate this data because the software is not accurate to that level. So that's what I have here. Since the error in the right ascensions of Arunti as well as Vasisht is higher than what is being measured, the epoch of Arunti cannot be determined. And this is a visual observation of that. Is that for every data, these are the error bars. So you have to give the error bars for every observation. And in that case, if your error is so high, then you cannot have any confidence in that data. And since this, in this case of Arunti and Vasisht, the error is much larger than what we are trying to measure, is in between, you cannot make any conclusion regarding that interval of Arunti and Vasisht. So then to conclude that Mr. Oak has claimed that Mahabharata could not have taken place outside of this range based upon Arunti moving ahead of Vasisht. But we have seen that if you look in the context, then this happens to be placed with a lot of observations that are out of ordinary. And that makes us think that actually the actual position was opposite of what is being said in this verse, and actually Arunti was behind Vasisht. Even if we take his date, then we know that it's Arunti would be ahead of Vasisht for over like 5,530 years, but Arunti is not shown ahead of Vasisht anywhere else in Mahabharata. We have gone through all the mentions of Arunti in Mahabharata. Now the time period itself kind of validated between the two software, 4,500 to 11,091 in Voyager, but in Stellarium software was a little bit different from 11,386 to 4,480. And in this time, there was only a 8.6 arc minutes difference in the Voyager 4.5 software. But this is an overestimate because that's measured on the equator, and the stars are far away from the equator. And if we do that calculations, so area difference between Arunti and Vasisht was 46 arc minutes, and so you can see that it's a big overestimate, while the actual distance is only 12 arc minutes. And we also know that the human eye cannot separate more than 5.5 arc minutes. So basically, we see that even if Arunti was ahead of Vasisht during that time, nobody could have figured it out. For anyone observing, it would have been same. So basically, what we have is that Mr. Oak has made a claim about the interval of Arunti going ahead of Vasisht, but he has not considered the accuracy of astronomy software. And the astronomy software do not have that kind of accuracy to determine this epoch of Arundhati. As the error in the star positions is higher than the maximum value of difference in the right ascensions between them, the epoch of Arundhati cannot be determined under the current state of knowledge. So I'd like to thank the host, Sutiji, and also Sri Rahul Diwan for giving me this opportunity. And thanks to the Sankam Talks team. This is my contact. If you would like to contact with me with this, I am open to questions. Thank you so much, Sutiji.
Thank you so much, Dr. Roy. It was indeed a very to-the-point presentation with a very sound reasoning. So now we'll open the session for the audience members if they have any questions to ask.
Yeah, this is Ashish here. The summary chart which Dr. Roy presented towards the end, that kind of confirmed the understanding that this entire theory of Arundhati walking ahead of Vasishtha has been built on projections of a software without even considering the error range of that software. So just wanted to get a reconfirmation of that from Dr. Roy, because it sounds really silly, at least to me, that you're making a projection, and this is for you, like you rightly pointed out, it's from actual observations of just for about 100 years. You're projecting to about 12,000, 14, 15,000 years without even considering what the error margin could be. And based on, without considering the error margin, you are making a claim which kind of debunks the entire traditional knowledge of crores and crores of people. So just wanted to get a reconfirmation of that from Dr. Roy. Is that understanding right?
Absolutely. You've got it right exactly. That's the whole, and you can see that it takes so much time to really refute these kind of claims. So you can see that so much calculations I have done, spent so many months trying to figure it out what is happening. And you can see that we have shown it in the very detailed calculations using two different softwares, and shown that that kind of accuracy does not exist, which is being claimed. So what is basically happening is that you are just basing the whole conclusion upon getting some numbers from the software, but those numbers are very, very small. They are within the margin of error of the software. So you cannot place any confidence in those numbers.
Yeah, I think, I would sincerely like to thank you and compliment you for all the research that you've done, because who otherwise would get into the kind of details that you have done, trying to see how the software has made the projections and are those projections right, and then checking what is the error margin of those projections. So, and that's a big problem, because with research and the kind of claims that Mr. Oak has been making, that it's perhaps how fake news spreads. It's like somebody just wants to believe that yes, it is so ancient. If you push it by another 10,000 years, perhaps there'll be a few more thousand people who will be willing to agree that yes, our antiquity goes back so by so many more thousand years. Everybody will be happy. So, and till such time that someone gets into such details and levels of research that you have done, the fake news keeps spreading. So, with a little bit of study that I've done, and with the more findings that you have given here, I really hope that this is a beginning of refutation of fake claims. in the name of science. And the biggest problem there seems to be that, it is being touted as real science when it is not. So
Exactly.
I would just like to thank you for that. And I hope it makes a beginning, the tide turns from now. That's all I would say. Thank you so much.
Thank you so much. Thank you so much. And in case if you have not seen my presentations on refutation of Ramayan's dating by Mr. O, they are already there on Sangam Talks. I think it was in February, March that I did a two-part presentation refuting the 12,209 BCE dating of Ramayana.